What happens now if you look underneath the radical sign if I put a variable? Uh-oh, same thing as before. Look for the primes, look for the pairs. It's all good. For example, you know x squared is x times x. Oh my goodness, guess what? There's your pair. Take it out. X. What's left? Oh, I guess times 1. So wouldn't this be square root of 1? Well, yeah, but do we really need to write it? No. You know and I know the square root of x squared is just plain old x. Look again when I have something with a number and a variable in this. Same as before. You know that that's 2 times 2. You know that this is x times x. Check it out. Check it out. 2 times 2, there's your pair. Pull one representative out. X times x, there's your pair. Pull the representative out. Guess what? There's nothing left. So guess what? Your answer, the square root of 4x squared, is just plain old 2x. That's how it works. So can we take this one step further? Absolutely we can. Take a look at this one. Same, but now the 48 does not square root nicely. Well, so what? So what? End up, if you're going to do this, end up using what? Break it down. 8 times? Yeah, 8 times 6 works. 8 times 6 is 48. Break this guy down to 2 times 4. This guy breaks down to 2 times 3. Keep going. That's 2 times 2 times 2 times the 2 that's here times 3. Start looking for pairs. The pairs here is 1, 2. There's a pair. So take a 2 out. Oh, look, there's another pair. Take another 2 out. Beautiful. And you're left with 3 behind. So that's going to be under the original radical sign. So far, I'm dealing with 4 root 3. But here's the question. Now I got x to the 5. So if you think about it, there's x times x times x times x times x. Oh, what a waste of time. Reason why is because you know you're looking for pairs. You're looking for multiples of 2. There's a multiple, take 1 out. There's another multiple, take 1 out. But there is a plain old x. So that stays under the radical sign, right? Because it doesn't have a pair matching. So what do you got here? Well, you got 4 and 2 x's, which is plain old 4x squared. You have a root 3 and a root x, so guess what? That's a root 3x. Done. That's how you do it. But can we do this a little bit simpler? Well, yes, we can. I want to look and leave this one the same. That doesn't change. That's still going to give us 4 root 3. But what I want to look at is, look, this was the square root of x to the 5. Now, do you remember what that means? Right here, baby. Do you remember flower power? Do you remember that at all? Do you remember how to make x to the 5 and square root it into an exponent? If you do, it's really easy. Take a look. There's the power, which I call the flower. There's the root, which I call the index. So the power is 5, the index is 2. If you put that into a mixed fraction now, you know that's 2 and 1/2. Guess what? There's the 2. Boom. There is the 1/2. I know you're saying, oh my God, what did he just do? Watch again, okay? Watch again. We'll do it again so that you can see it. Let me erase this, okay? Now, think about this. We had the square root of x to the 5, okay? What I'm saying is put this down as a fractional exponent, the thing that you learned in grade 10. So there's the power, there's the root. This works out to be 2.5. So basically what you've got here is x squared and x to the 1/2. Okay? So x squared out by itself, x to the 1/2 goes, because it doesn't have a pair, goes underneath the root sign. There it is. There's your x squared and x. Watch again when we do this question over here. Now, I'm going to need a little bit of room, so I'm going to erase some stuff here just to make things a little simpler for us. There we go. Look at this. 63. Well, I know 63 is 9 times 7. Break that down, 3 times 3 times 7. I'm looking for pairs because it is a square root. There's my square root. So 3 root 7 is 63 now. Now, let's deal with the n to the 7. N to the 7, remember, doing the square root of this means do this as a flower power. There's the power, there's the root, which works out to be 3 1/2, which means you've got n to the 3 times n to whatever is left, because that's not a whole number, right? So this gives me n to the 3 here, the square root of what's left, the square root of 1n. Look, there's the root 2, there's 1 left. Square root of 1 root 2. Okay? And then finally, let me clean this up a little bit because we need some room. Finally, we have the last one, which is p to the 4. So we got the square root of p to the 4. Now check this out. This is 4 over 2. Well, 4 over 2 is 2. Oh, okay. So this is p to the 2. That's it. Clean it up. You got a 3 here. You got a n cubed here. You got a p2 here. What's under the root? 7 and n. There you go. And that's how you solve these ones. A little bit more complicated, but the end result is, again, looking for pairs.